probably went up. Okay, so thank you very much for pointing that out. So now we should be recording. So yeah, so just to kind of give an overview of where this reconstruction software fits into the general scheme of things. We have right now a simulation that is working off of the DD4HEP geometry. And we can use this DDSim program, which will read that in. It's also capable of reading in generated event files in this HEP-MC format. And it will produce a file that is of type pod.io. This is just a root file. And then the reconstruction is another program that can read in from this and then write out to also a pod.io file, but, or to some other root file that has some customized histograms and trees in it. We'll go over that further into the tutorial because you have some options there. Right, so this is the general big picture view. We're definitely focused on just the EIC recon part in this tutorial. Okay, and I should encourage everybody, if you have a question or anything, you can either interrupt and ask me or write it into the chat, and we will try to answer it as best as possible as we go along. So I guess I should go ahead and move on to the next section here on the work environment. So I'm going to move this out of my way, or out of your way, so I have a terminal open here. And I'm just going to kind of walk through and show you how to get this up and running with EIC shell. So hopefully you watched at least the first tutorial, which gave some detailed instructions on how to set up EIC shell, which is a singularity container that has most all of the software stack in it and available so that you can be working off the same environment with things that you know should work together, the right versions, pre-compiled and everything, quick to get going. So here I'm going to work off of a JLab machine. So if you're familiar with JLab and have an account there, you can do the same thing, or you can just work off of your home machine or wherever you happen to have EIC shell set up. So I'm going to change into a work directory to start with. And let's see, I set up a directory earlier, had some stuff in it. I'm going to remove that, or maybe I should just move it out of the way for now. So if I'm on the JLab machines, then I need to make sure that I have Singularity available, and I use the 3.9.5 version. But however you prefer to start up EIC shell, this is just the way that I tend to do it myself. And then I will run, oops, that's not what I want to run. For some reason it's copied the wrong thing. Let me copy that again. See if this works any better. There we go. So I'm going to run Singularity, and I'm just going to exec the container and run the EIC shell within that, script within that, and that should fire up fairly quickly. There we go. Gives me a nice prompt. And then the first thing that you generally were going to want to do is make sure that this geometry is all set up. So I think that is not set up by default. And we do that by, geez, this is going to be painful if this thing keeps grabbing the wrong thing off here. Hold on. Try this again. That's better. There's a geometry that's already set up inside of the container, and you can just source the setup for that, and that'll make sure that your environment is set up to use the geometry that comes with the EIC shell container that you're using. And then at this point, at some point in the future, we will add the EIC recon repository, or the build of that repository to EIC shell, but right now it's not in there. And we want to try to go over mainly in the tutorial things that you might want to change in that. So you would need to be cloning it anyway. So to get the, oh boy, Maybe I should just type this stuff. Seems like I have to copy everything twice. Copy, paste. All right, so to get the software itself, you just need to clone it from GitHub. You can use your SSH keys if you have that available. And I already have this. I didn't move this out of the way like I thought. Recon.o. And I will clone it here and grab the entire repository. Once it is there, I can CD into it. I can run cmake. And I'll just tell it to use the source in the current directory, and I will have it create a build directory called build that will put all of the make files into. Those who are not really familiar with cmake, this build system does things in two phases. One where it scans through all the cmake configuration files, identifies what packages to build, and draws those in so it can add all the include directories and link directories and link libraries and compile time options, all that stuff. And it puts this into a set of files that it can just then run when you go to build the system using make. The modern way of doing this is you don't actually even run make yourself. You run make through cmake. Let's see if this one works. Right. So I'll run cmake a second time. This time I'll tell it that I want it to build and I want it to use the files that are in this directory called build that we just created. And the thing that I want it to do is install, which means it's going to have to build everything and then install it. The -- just means following arguments are things that will get passed on to make. And the -J8 then is to tell it I want to use 8 threads or 8 cores on the machine. And you can set this to whatever is available on yours. If you're on your own machine, you probably want to set it to however many cores you have. If you're on a community machine like I am, then I like to use a lot of cores, but I also know that I need to play nicely with everyone else. So I'll run it with nice that will just set the priority a little low. And maybe this will not take too long to build, but it'll use what's available. So here you can see it's going fairly quickly, and this will build a number of things. All of these Reconstruction factories, the EIC Recon executable. It will install a few other things into the EIC Recon directory, and then plugins for lots of different features, services, and such that need to access reading into the file, writing out to a file, and the like. So we'll go over a little bit of this in a minute. Okay, so there it's done, and it's done the install. Now, by default, you'll notice this is installing into the directory that I checked out EIC Recon into. So you can use the cmake install prefix to tell it to go somewhere else, but if you're checking it out and just building it without telling it where else to go, it's going to put it into your EIC Recon directory, and it manages to keep things separate because pretty much all the source is in this src directory. What gets installed here goes into a bin directory and a lib directory and an include directory at the top level right now. So if you're looking for things, that's where they are. All right. So I guess this brings us to the part where we have exercise 1, which is now, hopefully you've kind of been following along. If you haven't, I want to give you a couple of minutes to try and set this up in your working directory and build this yourself, because you'll need to have EIC Recon built to do anything else in the tutorial. So maybe I'll give you a couple of minutes and see if you can go ahead and do that yourself. I'll check on how we're doing on time. So I guess I should just also ask, does anybody have any questions at this point?
I have one thing to ask. What is podio output? What is exactly podio output?
So I'm sorry, could you repeat?
Why we called it podio output? Because it's a root file. We have the histogram and the tree. Why we called it podio?
Why do I call it pod? I'm making just a distinction there because, you know, root files are very rich in their internal structure. So you could have all kinds of different things inside of the root file. So it is a root file, but it is structured in a way that is compatible. I'm calling it pod.io. The pod.io people probably wouldn't even like that because they kind of gave the code as an example of how you could write to a root file. But it's the same format that is and structure underneath that's being used by what DDSim writes out and what we write out from the Reconstruction of here. So it's merely to make a clarification that if you have some utility that can read this format that they provide with this pod.io source, this should be compatible with that. Does that answer the question?
Okay, thank you.
Sure. Okay, is it maybe I get a thumbs up from anybody who's actually been able to get this to compile? Can't see everybody's there. I saw one. Good. I'll count that as good enough. All right. So at this point, we want to go on ahead and actually use it. In order to use the thing that you just built, you'll want to try to set your environment up to include it. So I will go here and see if I can. There we go. So there is a thing that gets installed. Whoops, this is not even the right command. I'm copy and pasting this. It gets installed into the bin directory here, and it's just a script, EIC recon-this.sh. We're trying to keep everything with just EIC recon at the beginning. So if you do that in tab, you might be able to find a command that you're looking for. If you source that, that should set up your environment. And now I will have EIC recon available if I just type it on the command line. And if I do this with no arguments, it will give me some help on what some possible arguments are for it. Generally, you're going to run it and give it one or more, sources, which will usually be a file, but it could be a stream of some sort later when we start getting into to those things. They're not in the immediate future, but further down. You can run it with things like -C to tell you what configuration options are available. You can run it with -L to see what factories are what JANA calls algorithms. So when you see the word factory, you should think algorithm. And that will tell you what type of object they are and what the collection name is under this tag for the different things that are available within that. So hopefully you've got this built now and you can just run it on the command line with no arguments and see the list of things. The one big or the most useful argument that you will have is the -P, and this is just the parameter argument. So there's multiple ways that you can pass parameters into EIC Recon. You have to configure it to do different things. One of the things you may want to do is tell it to please attach some plugins. And so there is a configuration parameter called plugin, and then you put an equal sign in what you want it to be set to. These can be given on the command line with the -P argument. You can also put them into a file that has one configuration parameter per line and with a space, and then the value after that. And then you can load that file with the -L and just give it the file name if you have a lot of arguments that you don't want to just write to the command line. Right now, don't give it the in threads. We have the current version of pod.io doesn't support this. So it would things just wouldn't work right. But in the future, when you want to run it with more than one thread, you'll give it a specific number of threads, or just tell it in cores, and it'll feel out how many cores are available and run that many threads. But for now, don't use that option. So it's pretty much going to be EIC Recon maybe give it some plugin or two, and then the root file, or the pod.io file is your input to it. Okay, at this point, we want to get a simulated data file so that you can run over some events, so you have something that you can play with. And we have put one up that you can grab from here if you use this command, the wget, and it's just posted on the web. And hopefully that just goes very quickly. It's only 55 megabytes. It's just got 100 events in there from some, I think it was some CITES events that were generated and run through the DDSim already. So we have that as just an input file we can, say, play around with a little bit. And now that I have that, I can just run EIC recon and give it that file name. And if I do, it'll start up, and then eventually, once everything is loaded, it'll start running through it. And it goes fairly quickly. You can see that right now it's running, 50, 60 hertz. It reads the events in, which is not terribly fast, but it's fast for reading the file right now because it's not actually doing anything. So I don't want to spend too much time because I know we're probably going to run a little late if I do too much more on this, but I want to take a minute to just show you the output of running EIC recon, because that tells you quite a few things. So we ran it up here somewhere. Yeah, ran it here, this command line. Prints out that it's JANA2. It attaches a bunch of plugins, and these are all plugins that are by default you generally want to attach. There is a way that you can tell it don't attach anything, and then you explicitly tell it what to attach or what to exclude. But the way we have set this up for the EIC is the EIC recon itself is pretty thin executable. It doesn't really have much in it, and most everything else is coming in from these other executable or other plugins that are built as part of the EIC recon source code. So it automatically adds all those in and attaches them. Then it goes through and tells you some information about what's available on this machine we're running on. iFarm 1801 happens to have 80 cores on it. And then it gives you a few other pieces of information, including this list of the factories that are available and the collections that they produce.
Can I ask a quick question on terminology? So
Yes.
you mentioned that factories are basically algorithms.
Yes.
What is the relationship between a plugin and a factory, if any, or are those completely independent?
No, that's an excellent question. So a plugin itself can contain pretty much any type of object that's in the JANA framework. So it can contain one or more factories, or it contains 0 or more factories. It can also contain what we call an event processor, and that will go over in a specific part of the tutorial today. So yeah, plugin, a lot of times when we're using the word plugin now, we will kind of talk about it almost synonymously with using it as an event processor, which is kind of a end game type thing, as opposed to the factory, which is an algorithm that is a utility that's used by the end processor that tries to see every single event. Yeah, I don't know if I'm saying that very well, but yeah, a plugin may contain a factory. It may contain any number of factories.
Okay,
So
thank you.
You can see that even here, like the barrel electromagnetic calorimeter produces 2 different types of objects here, or 2 different collections of objects. And some of these, and actually there's even more down here. So one plugin may contain a lot of stuff. In fact, you could have your entire reconstruction in one plugin if you wanted to. Okay, and then at the end of running, it does print out some statistics and other information that you may find interesting. Okay, so that doesn't really do anything other than run through the file. Hopefully that works for you. It's very quick. So the second exercise is to ask you to go ahead and do that. I'm going to let you do that in the background. And I'm just going to go into the very last part of this part of the tutorial so we don't go too far over time at the very beginning. And show you what you probably really want to know is not how to run over a file and not do anything with it, but preferably actually do something with it. So here I'm going to run it again, but this time I'm going to give it a parameter, a configuration parameter called pod.io output include collections. I'm going to set that equal to this reconstructed particles. And if you look up here, there's a thing called reconstructed particles in this list. So you can give it a comma separated list of things that you want it to write out to the output pod.io file. This time I'm just going to write out just reconstructed particles. These are including the charge tracks. So charge particle tracking will be done when I run this, and I'll run it over that same file. And when I run it, you'll notice it's a little bit different because all of a sudden it starts grabbing some stuff and showing you a bunch of things related to the geometry. Previously, when I ran it, it didn't require the geometry for anything. None of the factories were being activated. None of the algorithms were needing it. And so it didn't automatically do that. JANA tries very much to stick to an on-demand type paradigm so that if you are not asking for it to do something, it won't do it. And so by asking it to write out the reconstructed particles, that whole thing trickles down into requiring the geometry, so that gets read in. So now it's actually done it though, and we have those should be in the output file. So the default name of the output file is called pod.io output.root. And if I open it, hopefully this will work. Browser. It's kind of small. I'm sorry about that. But, there's a thing called events, a tree that's called events in there, and there'll be a thing called particles in that. And if you open that up, there's a bunch of things in there. At this point in time, not everything is filled out because we don't have full event reconstruction, but we do have tracking available. So you can look at the reconstructed momentum that's in there. And I think maybe there's a couple of other things that are available. Certainly the charge, everything's plus or minus 1 as it should be. A few more minuses than pluses. So, okay, so let's see. Oh, Suji, you raised your hand. You have a question?
Yeah, if I can ask a question here. Just wanted to understand how the dependencies works. For example, when we want to get the reconstructed particles, we actually need to get, for example, tracking, as you mentioned, and also some probably PID information.
Mm-hmm.
And but in the output, I noticed that it only provides you the reconstructed particles branch, not the, for example, previously in Gaudi, we will have tracking from particle from track fit or other information. I assume those are produced, but just not saved explicitly.
So yeah, there are some other things that I did not have it write out, but I don't know that everything is going to be there yet that was in Gaudi. There is a track parameters that gets put out. There is the central Kalman filter trajectories, things that are available for you to use. We do not have any real particle ID detector reconstruction though, so that's not going to really be there until we get that put in. And when I say we, I mean the collaboration at large, right? So this is a place where we're going to need to start drawing on more help from the collaboration to fill in some of these things for that.
Yeah, let me just clarify my question a little bit. So my understanding is that in order to get a reconstructed particle, you probably first already like automatically go through the track finding reconstruction, or you use the choose tracking information.
Mm-hmm.
I'm just wondering if, I mean, because it must have happened during this reconstruction process.
Yes.
Can you just write it down?
Okay, so you want to, yeah, so in order to do reconstructed particles, you have to have things like raw tracker hits, and the raw tracker hits are digitized values, or you need to have track seeds from somewhere, either from truth or something else. And so you're asking, how do you make sure that those other things that need to happen before it does the track fitting happen? Is that the question?
Yeah, I want to know, so if they happened, for
Yeah.
example, track finding or whatever, can we just save the output?
Yeah, so anything that is, it should be that anything that shows up in this list here, you can save that output as an object into the pod.io file. If it's not part of the data model, then we won't be able to save it directly into the pod.io file. It kind of has to be in the data model for it to be able to show up there. So yeah, that, and if you really want to save everything, you can do things. Well, you don't want to do everything. This will be a problem. If you do, one of the things you can do, if you don't want to add everything onto this list, hopefully we're going to eventually get this working correctly, but this is an issue that's with pod.io and not really with the EIC recon at the moment. But let me see here. Pod.io output file equals junk.group, say. And then I give it this. And this should start up, and it should, oops, maybe that wasn't what I needed to. Oh, what happened there? I don't want that. Not include file, just the output file. See if that works. So there you can see it's trying to write all of these collections to the output, just everything that it knows about. And it goes very slow when it does this. So it's not terribly practical to use at the moment. And there's also some issues with, I would say, cross referencing of some of the objects that I'm not sure that that's all being correctly written out. So there may be some issues with that. But if you really want to try to save everything, you can do this. And we have the include list. You could also do an exclude list where you say you want to write everything except for this, this, and this. You might have to play with that to find what is optimal for the things, to make sure the things you want get written out and not the things you don't that slow it down.
I see. Thank you.
Okay.
May I have one question here? So
Sure.
do we have the truth match ID, Monte Carlo match ID after the reconstruction? Because it will be required when we are exactly using the pattern recognition to understand the efficiency.
Right. So that's a good question, because I don't believe that that's in there at the moment. That there is the matching is automatically in there. So I don't know if there's somebody else who has more information than this. Oops.
And one more thing, I found the problem. I was running this. I run the simulation and I run the reconstruction. And in the reconstruction, I use the what we call is combinatorial Kalman filter, like ACTS. And then I have the truth ID. I am evaluating the momentum resolution. Nothing is coming out. It's every time it is returning the same number. It is really bit difficult. I don't know what is going on. Do we have some standard output so that I can process that output? If we can write some standard output, then everyone can produce it. Actually, that is a.
Yeah, I think that what you're asking for is you want the matched truth information with the reconstructed tracks.
Yes. Right.
That's what you're looking for. And I'm not sure that that's in there right now. And we'll have to talk to some other ACTS experts or the tracking expert. Maybe Dimitri wants to say something about that.
Yes, I just wanted to say that this is something that we're working on actually with Shyam. So this is probably out of this scope of this tutorial, and we can talk about it offline. So Shyam, after this tutorial, if you like, we can talk, or have anything else change.
Yes, because we are discussing today with our group, they said matching is not really simple. I don't know, but I don't know.
Yeah, it's short answer. The matching is the matching algorithm is something that I'm working on. Actually, I ported now from the juggler and finishing it, and I think that like today, tomorrow, this will be in place, and you can try this.
Okay. Thank
It's
you.
the status. Yes. So I know that you want to report before the Thursday, so I will try to give it to you today or tomorrow.
Okay, and so maybe in the interest of moving on, I see Tyler has his hand up. Do you have a question, Tyler?
Yeah, I just wanted to ask, and if this would be more appropriate at another time in the tutorial, feel free to let me know. But so like looking back on the experience we had with for instance, simulations with Etche, there was reconstruction of tracks and clusters in Fun for All, but there was a point where, for instance, the calorimetry group said, oh, we want to change the clusterization algorithm, so you shouldn't use what's there. You should use this other software that we have. So I just wanted to get an idea for the reconstruction that's being done in EIC Recon right now. Is that fine to use, or is that something that's still really in flux? And
oh, it's really in flux. And one of the main purposes of this tutorial is to try and inform people who are interested in going in there and writing these algorithms and refining them, so they have the tools they need to start doing that. Most of the effort that's been going on up to now have been people that have been trying to simply get some software structure in place so that detector and working group experts can come in and do this kind of refinement in there, if that makes any sense to you.
okay, that does make sense. Thank you.
So hopefully these next sections will make things a lot more clear on how to do this stuff. So at this point, I'm thinking we should probably move on to the next section. That I think, let's see, Thomas, you're gonna
Yep, I'm here.
talk us through that. So I'll go ahead and mute my mic right now.
Okay,
Go ahead.
let me get my screen shared and this screen. Let me pull up my notes. Okay, yeah, so what we should be at as a group is able to be in the EIC shell, and we've sourced our detector geometry, and we're going to sit down and start to make a plugin. So just to kind of reference the earlier question a bit, I like to think about it, the plugin is where you are asking for things. The factories are what give you those things that you're asking for. The plugin is more consumer side. It's not strictly true, but kind of the general framework I use mentally. So I'm on an iFarm machine, and I have a directory that I've called tutorial in all caps, so I wouldn't misplace it. And we're going to start by using a helper script called EIC make plugin. And in order to have access to it, we need to have sourced EIC recon this. I'm guilty of often forgetting to do this step and then going, why can't it find it? So I'm going to go ahead and source it again here, just to make sure I am absolutely 100% here. And I see EIC make plugin is found. So let's go ahead and make ourselves a plugin. What we're going to do is we're going to call EIC make plugin, and then we're going to give it a name. I think a good name is my first plugin. Feel free to alter if you prefer a different name. And then when we hit enter, we see we get some text in our terminal. It tells us what it's doing. It's writing a CMake list file, .h and a .cc for our first plugin processor. And it also gives us this handy guide on how we build So we'll have to store this back in our mind in just a bit. So what it also happened in the background while we ran this is in the same directory I was sitting in, I have a new directory called my first plugin. Now, in order for us to like build and use our plugin, we really need to let JANA know where we're working. And so we're going to create a directory to hold our plugins. We're going to call it EIC Recon my. You can call it whatever you want. And then what we're going to do is we need to export a variable. The variable is EIC Recon my, which is why I named the folder same. And then we're going to set this equal to the directory just created. And now we are properly set up for JANA to know where we're going to be storing our plugins when we build them, and the system can work. Yeah, not having EIC Recon my will result in when you run it, it will, I don't know where it by default will put your plugin. It's possible that when you run it in JANA, it will not find it. You'll get an error that's like, I can't find your plugin. So we make sure this is set. Then let's follow the guidance that's up above. And I'm going to, just like when we were building EIC Recon, I'm going to call the cmake command, sets up the kind of install file, and then I'm going to tell it, okay, actually build my plugin. And I'm going to pause here for a second, just to make sure everybody is keeping up. If I could get some, I guess, thumbs up if you are at this point. Nothing too complicated, but
Sorry, could you
don't
just
want
go
anybody-
two commands and show me what the first one you did? Okay,
cmake -s my first plugin -b my first plugin /build. It was also the thing that's written out when we first made our plugin. It's the first line of the build. So if you need to reference it. As a handy hint, usually when I'm doing development with plugins, I end up making a script that's called like build plugins. And as I make my plugins, I just add to the list. So I just call build on them, and then they all build. But that's more, I guess, more advanced when you start getting into the workflow of using plugins. So now that we, I see there's somebody in chat. Oh, okay, sorry. So now we can actually look, we built this, and if we take a look in that directory, EIC Recon my, we should be greeted with a folder that's been created, this plugins folder. And if we look in there, look, there's our first plugin. We successfully built it, and it ended up putting it under our EIC Recon my, just like it should. Now we can, if we're really paranoid, we can test to make sure it finds the plugin. And we can do that by running EIC Recon with -p plugins equal, and then my first plugin. And then there's this JTest plugin. And we don't want to run for an infinite number of events. And we're going to just tell JANA how many events we want to process. And this is just a test, so let's just run 10. You get a similar dump out that we saw before that David was showing. Same information is printed out about the node. I think I'm working on a different node, so it's got more cores. But you can see down here, initializing JEvent processor, my first plugin processor. So it did find it. it's actually using it. It's using a dummy source. That's what the J-test is doing. It's just dummy data, just to prove that, hey, we found it, we built it, it closed a histogram file that probably has nothing in it, and there we see, yeah, it did. So we see evidence that it found our plugin, which currently does nothing. that's fine. And it is actually runnable by EIC Recon. Have any questions? Everybody keeping up? We're going to get into it now. We're actually going to make a plugin to give us some information. So what we have inside our my first plugin are the .h and .c. This is VS Code. It's what I use. I'm currently on the Windows box off campus. So yeah, this is what I use. I recommend it. I like it a lot. But if we look first at the my first plugin processor.h, we're greeted with a class and a few includes. For example, th2d needs to be in there, tfile because of the root access stuff. And then the JEvent processor sequential root.h. So the skeleton code basically knows, hey, you want to make a plugin. We're going to make a JEvent processor sequential root. You can see it's public here. And it creates a class with your defined plugin name. Let's take a look at ecal barrel hits. Let's look at the energy distribution. Why do I choose this one? Because it's right here, and I'm lazy. If we're going to look at these, you'll notice commented out, it needs sim calorimeter hits. So we are going to need to include those objects. So I'm going to uncomment out, include medium for HEP sim calorimeter hit. Great. And then we need to issue this line. And I just want to focus on this line for a moment. Prefetch T, it's basically saying, hey, JANA, there is something of type sim calorimeter hit that's tagged with this string. Go ahead and get for me those things. So this ends up being a vector of ecal barrel hits, which are of type sim calorimeter hits. So that's what the prefetch does. If you wanted to get other types, you would need to state you want other types and give other tags. We have some exercises we'll get to in which you'll play around with this just to see that you can change it. Now, I want to make a histogram. So we need to, as a private member of ours, we need to have our histograms that we're going to write out. This one looks good. It's going to be a TH1D. It's just going to be a histogram of the energy of the raw hits being defined up above. And that is all of the uncommenting / coding we need to do at this moment in this file. So let's go ahead and save it, which is great. Now we need to move to the actual engine, the .cc. You can see here, we have a root file service, which is being invoked. This is going to be responsible for getting our histograms into that EIC Recon root file without us having to do a bunch of work. I'm all about that. So we see that when we init this plugin, we're going to get the service, we're going to get the histogram file, and then we're going to make a directory called with the plugin name and move into that directory. Now, remember, we set to a null pointer before. We really need to define our histogram. So he raw equal, and this is just going to be a 1D histogram, 100 bins, 0 to 0.075. But that sets up the histogram. Now we need to fill it. That's what process sequential does. So you remember we had that prefetch that was sitting out there in the .h. that allows us to basically call a line like this. For every hit you find in raw hits, and this is going to basically say, there's a factory that's producing this type of hit. I should use that factory to give the vector of hits. Or I should use this factory to give the clusters, or whatever the factory, whatever the object is that you desire in your process. And then we're just going to, for each one of these, and I'm not a code minimalist, so I'm just going to put this for future. I think it's a little cleaner for me to read. So we go for every hit, we fill the energy on our histogram. And that's it. We actually are ready to save this. And I'm going to take a pause for a second and let people kind of catch up. I see there's chatter in the chat. I'm looking at it now. Okay, so some people are having issues with the install. David, you're helping them out. So let me pause for like 2 minutes and see if we can get people at the point where they're ready to run.
Thomas,
Yes.
can you make the text on your screen just a little bigger?
I will try to do that. Let me see if I can. Is that better?
Yeah, that's much better. Thank you.
Okay, yeah, sorry. I've got a decent sized monitor at home, so the resolution's getting a little funky. Your EIC Recon My folder should be empty up until the point where you actually compile your. If you've compiled the plugin, yes, and then there's this. There was a bug we found in doing this, which should have been fixed this morning. If JANA is not finding your plugin, it will complain about the JANA plugin path. And so David has put in chat the command. That's the workaround. You force it. You say, hey, make sure you're looking in here. So yeah, if you didn't pull the latest main, as David already pointed out, things are in flux. Some parts of it aren't quite set in stone. Okay, I'll give a couple more minutes. It's good that people are running into issues that we're trying to address here now. And then the important bit that I forget from time to time is, since we've modified our plugin, I can underscore the fact these plugins are compiled objects, which means they're not like Python scripts where you modify them and then you run them again and then they just on demand take your updates. So we actually need to rebuild our plugin. And I, out of paranoia, run both lines. I don't think it's strictly necessary, but I just make sure everything seems to be. Oh, whoops. I typoed a thing. Of course, hit is a pointer. Auto hit, it's a pointer. I just did a dot because I made a mistake. And it was caught at compile. Let's try that again. Yay. Okay, good. So now I should be able to run. We should run over data, and I'm going to use the same data file that you already downloaded. So I cleared out my directory to make sure I was starting from as scratch as I should. So I'm going to go ahead and wget that file. If you've already done it from the last episode, you should already have it. You do not need to do this again. And then the familiar EIC recon, and then we need to tell it our plugins. In this case, we're just going to run my first plugin, and we're going to run over that file that I just downloaded. David, you have your hand up.
I just wanted to, well, make a side comment based on the discussion that's kind of going on in the chat to clarify a little bit. This EIC recon my environment variable and directory, those are really set up for, in the future when you start using a build of EIC recon that's packaged with the EIC shell or maybe available on CVMFS, someplace where you don't have write privilege. You're going to need to have someplace that you can build and install your customized plugins or factories to that may be outside of that read-only place. And so that's what the EIC recon my is intended for in there. So I didn't make that very clear before, but that's the intention of being able to build against a read-only place, but still have an install location that is for your dedicated things. So that was it. And Thomas, your screen is still really tiny there. I can see the code behind it, but
yeah, the terminal. Yeah, let me see if I can. Properties probably. Make it much bigger.
That's
that better. Okay. Sorry about that. I didn't do any font size checks. Should have. So what I've done in the meantime is I've gone ahead and run this EIC recon with my first plugin over that downloaded file. And we see a similar output like we did when we just ran the test. Except this time, fingers crossed, we now produce a root file, and this is really tiny, and I do not know how to make this bigger. The little root. We should have our root file with the directory with my first plugin. That's the name of the directory. It's that named because in our code, right there. So if you wanted it to be named something different than your plugin name, you can modify it here. I'm choosing not to because, yeah, to each their own. And in it, we have a single histogram. Let's see if I can. And in it is filled with 114,000 some odd hits. And I'm just going to zoom in on a portion. And this is the energy distribution of the barrel electromagnetic calorimeter. That is in that file that we downloaded. So I, instead of putting the exercises in the midst, I figured that it might be best to kind of give the exercises all at once and leave enough time where people can ask questions. David is here, I'm here. We have a few other team members that can hopefully jump in and help. And take a little bit of time and try to plot like the X and Y positions of all the hits. So we have right now, we've just got a histogram, right? That plots the energy of these hits. We can get the position. So try to create a histogram. It's like a 2D histogram that plots the positions of these hits. And then try to apply a cut. So maybe, I don't know why we would, but let's say we only cared about the positions for hits greater than 0.005 GeV. And so this type of activity is closer to what you'd experience if you're trying to do a physics analysis, or kind of the seed of an analysis where you might apply cuts. And as a hint for exercise 2, it's going to be your process sequential that you want to modify, right? You're picking up each hit and you're asking about its energy. Well, here you can apply an energy cut. And I don't know quite how we're doing on time, David. I don't know how much time went to allot to have them battle through this.
Let's see, I think we're okay.
Right.
at this point.
So yeah, just raise your hand if you have any questions, and I guess write in chat, and I can get access to the chat. I'll try to do a better job of watching chat. And see if you can get to the point where you're getting a histogram out, and then see if you can get to the point where you can produce a novel histogram with a cut. And when you're making modification to the code, do not forget to rebuild your plugin. I'm laughing mainly because this morning I was running over things and making sure it worked. And then it didn't produce a histogram. So it's an easy thing to forget and miss, especially when you're under time pressure and you're feeling rushed. So don't forget to do it. So Max plus Docker are sluggish.
I haven't run, even though I use Mac all the time, I've not bothered trying to run inside of Docker. I've just been running on Linux, some other central machine running Linux. Or my desk, I have a desktop right here also that runs Linux I can use with Singularity. So that'll be something we'll have to investigate. I don't know if that's something unique to the Mac and Docker setup, or if it's just an exasperated reflection of some of the other performance issues that we've been fighting with for a little while.
Yeah, sorry, this is Norbert. I mean, I'm trying to use it, but it's really, really slow, and it's not probably my Mac because it's an M1. Okay, not M2, but still should be much faster. So it might be some M1 plus Docker. Maybe the Docker is not improved. I don't know.
That's possible. Yeah, we may have to try looking at it. You do not, well, yeah, it's not really a good answer for you to say, do you have access to a Linux machine? So, but yeah, this will be something we'll have to try and debug and see if we can reproduce it.
Yes, I mean, almost everybody has access to some cluster or something, but I mean, if you just want to do something quickly online, I mean, on your offline of your laptop, then yeah, it's
one of the things that part of the thing is to do it, to really take advantage of a containerization here, so you don't have to build everything yourself. You kind of have to use something like Docker on the Mac, and if that's if it's the issue with that being unperformant, we may be a little bit stuck on that. But it's a good point, and I appreciate it. As a Mac user myself, I appreciate the desire to be able to run things locally. So we'll look into this.
Is there somewhere where we can view like class references for EIC Recon, like a Doxygen page or something, or is the best resource to just look at the actual source code?
That's a great question. David probably has a better answer. One kind of cheater way is actually when you run this, you can see the objects and their tag.
Yeah, but you really want to know what's inside of the,
Well, yeah, I mean, so for instance, you
Yeah.
know, we're iterating over all of the hits in this hit collection, and I'm just kind of curious, like, if I just wanted to look and see, okay, what pieces of information can I ask for
yeah.
this object?
So the way I do it, again, there's probably David probably has a better answer. The way I do it is I actually downloaded or cloned like EDM for HEP. And then the IDE just lets me kind of control click and it sends me there and I can see the, function
yeah,
calls.
I'll admit, I haven't gone looking outside. If you have your IDE set up, it does all that work for you. And it's much faster than jumping back and forth to some web-based documentation. But I suspect that there is a web-based Doxygen somewhere for the EDM for HEP and the EDM for EIC. But maybe Wouter wants to say something about that, because I think he was online. But
Yeah, I
maybe-
mean, I'll second that because I'm just using, Emacs, and yeah, like if I want to call, I can open the input file and see what members are there, but I don't know the access functions from EDM for HEP or PODI or whatever it is.
So what I've gone ahead and done is up on my screen that I'm sharing now is the EDM for HEP sim calorimeter hit, which should be sufficient for these exercises. I expect in the future, like a Doxygen or whatever would be coming, because yeah, it's kind of gnarly to have to go to
It's
the
a good
source code.
question because there is you're right. There's at least 2 people already who have said it out loud, and probably 3 others who haven't bothered saying it, that they would like to know how to do this. So we should look at how we can make this really easy to get to. I know that in the continuous integration system they have set up, there was some recent work Wouter was trying to put in to get the EIC Recon built, Doxygen documentation for EIC Recon built. So that's why I would say I'd be a little shocked if he didn't already do that for the, or have someplace we could point to for the data model structures themselves. But I don't know where that is off the top of my head because I just haven't used it. But I'm going to write that down so we can get that linked somewhere. Okay. So right, I think we're at a point now where we need to probably
Move to
ready to move
factories.
on. Are you ready to move on, Thomas?
I am if people are. I just put up on the screen, so I have the 3 calls, so the energy and position info, and then I went ahead and while we were discussing, produced the XY. And it looks like a barrel, which is good. Which is good. So yeah, thanks everybody. And it is, once you get used to how the plugins work, I will say it is pretty easy to work with. It does a lot of the heavy lifting for you, as long as you know what calls to make, which is the hard. Okay, I'm going to stop sharing my screen, and I think Nathan picks it up for factories.
And I was just saying, Dimitri did post a link in the chat that points to the YAML file that defines the data model, which will give you probably most of what you need. It's not the C++ code, but it is a reference to what's defined there in the structures. So anyway, sorry, Nathan, go ahead.
No worries at all. Take your time. I'm just gonna start a screen share. Now, guys, can you see my screen?
Yes.
Excellent. So I'm going to be talking about factories, and I'm going to start by just giving you more of a basis about what are factories within the context of JANA. And then ultimately, I'm going to point you at the generator and then have you generate your own factory and add it to your plugin. So I just want to start by talking about, like, so what are the different JANA components? And so with JANA, you have an executable, and then you have a plugin, and then the plugin just adds functionality to the executable, basically. But both the executable and the plugins can have any number of components, and the components are Jfactories, JEvent processors, and JEvent sources for now. And so you've seen a JEvent source in the form of the JTest thing, which just created events. The JEvent source that you care about most with EIC Recon is the pod.io event source. And you've just written your first JEvent processor. And so now we come to JEvent factories. And it's very good to like understand the difference here. So if you think in terms of like parallel programming, you start with a shared resource, which has to happen sequentially. And then you need to do a whole bunch of computation, which you really badly want to do in parallel. And then you ultimately write back to a shared resource. And so for each of these three stages, you have a separate JANA component. And the reason we've broken down that we have is because you want to have the JEvent processors to aggregate whatever results from each event into some sort of structured output, and that's like a histogram or a file. And then all the computation itself, the heavy lifting, should really go into a Jfactory instead. And it's important to note that you don't ever have to use a Jfactory. You can put any code you want into your JEvent processor's process method, but I would strongly encourage you to put as much computation in a factory instead. And there's some very good reasons for doing this. Like it makes your code reusable, it makes it modular. Different people can go and use your same intermediate results. And they don't have to understand the specifics of what you did. But then if they decide they need to understand the specifics, they know exactly where to go. So this has been it's essential for just managing the complexity of the code base. And then the other big thing is, well, this code has to run multi-threaded, but we don't want to have every single person having to deal with threading primitives, and we want them to be able to write code which doesn't have to be thread safe, and the Jfactories let you do that. And so the Jfactories give you a particularly nice dynamic when it comes to getting the results. So you can really just say, get me this type of data that has this type and this tag, and JANA will figure out what Jfactory provides it. If nobody ever asks for that data, the factory won't run. If the results are already in the input file, then it won't try to run the process method. It'll just use the results already found in the input file. If multiple people need this data, it only gets calculated once and then it gets cached. And then if the Jfactory needs data from other Jfactories, it will call it under the hood. It'll be completely seamless and transparent. Now, there's been a lot of talk about what is the difference between an algorithm and a factory. And this really goes back to like computer science, like basics or software engineering basics. So a factory, just outside of the world of Reconstruction frameworks, a factory is just a programming pattern for constructing objects in an abstract way. The factory doesn't, like it knows how to construct them, but it's really concerned about getting the user the objects so they don't have to construct them themselves. And more importantly, so the objects don't have to construct them themselves. Like the factory takes on the responsibility for constructing the objects. And so happens that in physics, a lot of this object construction is actually really computationally intensive. And the thing that is doing the computation is an algorithm. And so the algorithm could be extremely generic. So if you have a factory that produces cluster objects, and then it calls a clustering algorithm. So pretend that we're dealing with the barrel calorimeter. The clustering algorithm doesn't care about barrel calorimeters at all. All it cares about is energy and positions of hit objects. So you could, in theory, have one algorithm that works for any kind of calorimeter or whatever. And then the different factories which produce very specific things in the domain language of, the EIC, all ultimately go down to this generic algorithm. So now let's bring back the concept of, JANA and Gaudi to all of this. So JANA has this thing called the Jfactory. And then, when you call Jfactory process, then that will be calling some algorithm, which could be in the body of process, or it could be its own piece of code somewhere. And then Gaudi provides something called an algorithm, which is really more like a Jfactory. And so if you just want to translate the Gaudi speak to the JANA speak, all you have to do is translate the word Gaudi algorithm to Jfactory, and the collection name becomes the tag name, and then you're pretty much good. But we're trying to go a step further. So we have this concept of generic algorithms that, both the old Gaudi code and the new JANA code can run. And then this is nice because it gives you another level of things that you can sort of test independently. All right. So the other critical thing to understand about Jfactories versus JEvent processors is the JEvent processor is sort of observing the entire event stream. So this is it's similar to like fluid mechanics, where if you're examining a fluid flow, you can either have like a little window on a fixed point in space and then observe how the flow, changes at that window, or you can attach the window to the flow and then the little window like moves along with a little fluid particle downstream. And so the JEvent processor is really sort of that, little window that's fixed in space, and it's just observing this entire event stream. And then it has to have a critical section where basically it only allows one event through at a time so that it can update a shared resource. But the Jfactories, on the other hand, each of them only ever look at a single event at a time, and then they work on that event independently. And so you can say each worker thread is given an independent event, and that event has its own collection of Jfactories. And then when you trigger that Jfactory, it can do whatever it wants in that thread on that event, all nice and independently. And you don't have to worry about making each Jfactory thread safe. And so you're perfectly welcome to write your Jfactories in a functional style similar to what Gaudi wants you to do, or I guess what Juggler wants you to do. I'm not sure. I'd say that Gaudi wants you to do that. But with JANA, you also have the option of caching data on the Jfactory. And you really want to do this when you have things like conditions or geometry data or anything where you'd want to be doing a deep lookup to retrieve this, additional data for every event. Like you want to avoid accessing the shared resources on every event for performance reasons. And so instead, what you can do is if you know that this shared data you have changes with the run number, for instance, then the Jfactory has a callback called begin run. So you can say, every time we see a new run, then go ahead and reload our geometry objects or whatever. Now, it's important to note that just because the Jfactory can be called in parallel, it doesn't mean it will. So for instance, when you wrote your JEvent processor just now, and you wrote this process sequential, everything that's happening in there is happening sequentially. So if you call jevent.get, it will happily call jevent.get, but it won't give you any of the performance benefits. So the reason we have this little prefetch abstraction is so that you can tell JANA, this is something that we're going to need, so go ahead and calculate it without having that lock. And then that way it'll be present so that when you do acquire the lock, you can do the minimum amount of work with that lock acquired as possible. Yeah, so that's just an argument to understand how the JEvent processor works with respect to that. There's, a parallel section and there's a sequential section. And in the parallel section, you can call event get or call prefetch, which will call event get for you. And then in the sequential section, try to avoid calling event get. It's also a really good idea to not have a big piece of shared data directly attached to your Jfactories. So like there's nothing really stopping you from having a pointer to your magnetic field map directly in the Jfactory. But again, if you want to, access that, then you'll need to write locks to make sure that the access to that shared resource stays safe. And for this reason, we strongly encourage you to not just have big blobs of stuff stuck on the Jfactory, which would force you to, add thread safety around that, but to use this JService abstraction instead. And the JService takes care of that, and it gives you like a copy of whatever you need that you can then deal with independently. All right, so how do we use a Jfactory? It is very easy. So as you can see here, we have these clusters. We say, we want some clusters. We're going to take our event and just say, get me these EDM for EIC clusters that live at this tag, or that use this collection, that belong to this collection. There we go. And these clusters, that variable is going to be a vector of pointers to EDM for EIC cluster types. And you can then just iterate over them and do whatever you want with them. You aren't allowed to modify them because we have this constantness constraint, but you are allowed to copy them and chop them up. All right, sorry. Let's stick that over there. Okay, so now, one important thing is the question of how do we swap factories in and out? And basically, each factory is uniquely determined by its data type and by its tag. And then obviously you can't swap out things with different data types because that would break, the type safety of the whole program. But you're perfectly free to swap out tags. So if you have a factory or a processor that, wants a factory, you can totally just create a variable that says, what is the tag or what is the source for this data type? And then use that tag to retrieve it. And then you can make that tag be a parameter, and then you can change it at runtime through the command line, whatever you want. And we have conventions for doing this in a controlled way, which you can see if you look at some of the existing factories, but this is something to be aware of when you come to that point. So let's look at the things you actually see in the Jfactory API. So the most important thing, so this right here is an example. It takes protoclusters and it produces clusters. The most important thing is that we're inheriting from this Jfactory T header file, and Jfactory T, basically we're adding in the type information. This is a Jfactory that produces EDM for EIC clusters. And for now, we're going to just say that every Jfactory produces objects of exactly one type. And there's some patterns we can use if you ever need more than one type, but we just strongly encourage you to decompose the problem such that each factory gives you only one type. And now we come to our constructor. And for a constructor, the only thing we really need to do in our constructor is call this set tag method. And that is very important because that is how this factory, this is how JANA knows that this factory is tagged as ecal and cap n island clusters. And now if we go back to here, you'll notice that we have a naming convention for these things. So we have this cluster underscore factory underscore ecal and cap n island clusters. Basically, it's object name underscore factory underscore tag name. And this convention looks a little bit weird at first, but works out really well in practice for a bunch of reasons. All right, and so we've created this Jfactory T. We've told it that we're going to be producing clusters. We've told it that it has a collection name of ecal and cap and island clusters. The class is named in a way which is really predictable. So how do we go about, working with this? So the first thing we want to do is we want to initialize it. This gets called exactly once when the factory is created. And so the first thing you want to do in your initialization method is obtain the JApplication object. And this gives you an interface so you can do things like get your configuration parameters or get services. And services would be things like geometry or DD4HEP or what have you. But here we're going to just load a simple floating point value. And then this is a parameter, so you can just set it on the command line exactly as you've seen before using the -p. And you'll notice we have a naming convention. So we go plugin name, factory name, or sorry, factory tag name, and then variable name. And you just call set default parameter, you pass it a reference to where you want the data to go. And then this argument here is that is the explanation about what this is, so that, when you query JANA for all of the parameter options, it will tell you that. And then the other thing you might want in init are services. And the idea, so we have this logger service, and we're just going to say app.getService, pass in the log service, and then we're going to get a named logger. I forgot to update the name, so that shouldn't be JEvent processor pod.io. It should be ecal and cap and island clusters. So sorry about that, but I think you get the idea. So the idea here is that you just ask the logging service for a configured logger, and then you can save that logger down to this mlog member variable. And as you can see, the two pieces of state that really live on this Jfactory are the scale factor parameter and the mlog logger. And these are pretty much for whatever member variables you have here, you should really be setting them in it pretty much. And then we come to process, and process is the thing that does all the computation. And process is given a shared pointer to a constant J event. And this is where you take some data from the event and run some algorithm and then set the output data. And as you can see, we are obtaining these protocluster objects, and these may or may not have come from the pod.io file. They may or may not have come from, the Jfactory for protoclusters process method. So it's completely transparent to us, the user, where it came from, as long as you can get it. And then we can do whatever we want with the protoclusters and stick an algorithm in here. And I can point you to a simple algorithm, which is nice and fun. But ultimately, we end up creating a bunch of these new cluster objects, which is what we're trying to output, pushing them onto this output clusters vector. And then when we're all done, we call set. And what we're doing with set is we're handing ownership of these objects to JANA. So they still actually technically live in the Jfactory, but you as the user no longer need to worry about them. JANA will hang on to them as long as they're necessary. Once all of the event processors have finished running, and once the event source has been notified that it's done, then JANA will just delete that data for you. And if you don't want it to delete the data for you, there's a flag that you can set. You can say you're not the object owner, but I wouldn't recommend doing that to begin with. That's really more of an advanced technique. So in summary, just create your output data and then stick it in this vector and then call set and then let JANA handle the ownership. All right, so now that you've created this Jfactory T, now pretend that you want to add this to the plugin that you created half an hour ago, and that's very easy to do. So you go back to the plugin's init method, and you just have to add this Jfactory generator T object, which lives under JANA/Jfactory generator.h. And the whole point of that is that you don't know how many factory instances will be produced. You can be pretty confident that there's going to be as many factories as there are events in flight, but there are some technical reasons why there might be a lot more than that. So basically, you as the user aren't responsible for constructing the Jfactories. You're just pass JANA's Jfactory generator, and then JANA will construct however many it needs. And then this brings us to how do you actually generate a Jfactory skeleton so you don't have to memorize all this stuff. And there's a script, it's called JANA-generate.py. If you set up your EIC shell correctly, you can just type JANA-generate.py. It generates a lot of different skeletons for JANA things, and it's not specific to EIC Recon. So we expect we will be adding an EIC specific version of it, just like we did with EIC make plugin. So EIC make plugin is basically a customization of the JANA generates plugin. But so if you want to generate your Jfactory, then you just call JANA-generate.py, tell it to create a Jfactory, tell it the object type, and then tell it the collection name type. And now this will generate the CC files and the H files. It is using a different naming convention than we would like, so that will be changed in the next version of JANA. And obviously, when we get around to putting the EIC make plugin in place, then that will also it'll be in there. And then the other thing that it does is it generates a stub definition of this EDM for EIC cluster.h, and you don't want that. You want to use the real one, so just delete that file. But yeah, so you can just go ahead and create a stub factory, and then you can call it from your event processor that you've already created. And I would recommend doing something really simple. So like taking like your hit objects and just, shifting, I don't know, one of the values, and then, generating a histogram showing the original values and then showing the shifted values, for instance. But it's a good way to play around with creating a Jfactory. All right. Does anyone have any questions? This is where I discover that my Zoom died on me. No, it did not. Ooh, somebody raised their hand.
Yeah, can I just ask my question? I'm Shujie.
Absolutely.
So just wanted to understand the big picture more. In the beginning of this tutorial, David showed us how to run the EIC recon.
Yeah.
And I remember there were options like what plugins you want to use. Just wonder how exactly that works. So previously, in the previous session, we also learned how to create plugins. And so what exactly EIC recon called?
Wait, you mean what factories does EIC recon call?
So when we tell EIC recon that we want this plugin, what happened?
Oh, so all right, so you have this EIC recon code base, which has a whole bunch of its own plugins. And then those plugins contain some factories. And then you've written your own plugins probably, which also contain some factories. And the idea is your factories can pull in whatever factories are in the EIC recon plugins that have already been loaded. But you can also basically add things on the fly in really nice ways, I guess. Did that answer your question at all?
Yeah, sort of. Thank you.
Maybe the part of the answer, when a plugin, if you're asking more of a technical question, when the plugin gets attached, this init plugin routine is found in that plugin and it's run, which allows the plugin to add all of its components into the central JANA framework. So it may add in factories into the big pool of factory generators, and it may add in processors into the big pool of processors that get called. So, so that's why we can extend a single process with many plugins that will just each add more factories or processors to it. But it's in such a modular way, because if you wanted to just run a very simple case program where you only needed a couple of plugins, you might just do that. And you could test that plugin outside of the context of everything else. And so it tries to really go to this modular form or principle from our software statement of principles. Maybe I'll just make another very quick statement in case it got lost there, because in any of this, if you're going to make a clustering algorithm, put it in a factory. If you're going to make a histogram of the energy of clusters, put it in a processor.
That should have its own like colorful box on this tutorial,
Can I-
now that I think about it.
Yeah, can I make one more step back and actually tell, kind of recap on one important thing? So plugin technically is just a shared library, like a regular SO library, and that's it. The only difference with all other libraries in your machine, which is a lot, is this init plugin method, which is on top of Nathan's screen right now.
Oh,
So
okay.
yes, so technically what happens in the beginning, JANA goes to this through this environment variable called JANA plugin path, and looks on this plugin flag which libraries to load, and then or some default plugins that is there. So then it just loads these libraries, and for each library, it runs this init plugin function, where a library can add what functions, what factories, what processors, whatever they would like to add to JANA. So after this loading, so what is important here? The plugins are just libraries. Plugins is something that you compile in order for JANA to pick up your code. So it's kind of to make it modular. You don't compile everything in one blob, you just compile a little library that JANA pick up. So the other important thing, which I think that we have to go, for example, on tomorrow's tutorial, is that in JANA there are 4 types of objects, kind of 4 basic type of objects. First and second, called factories. Factories produce objects. And the second one is event source. It's the same as factory, but they kind of gets input streams like read event files, read from DAQ, whatever. So they're pretty close to the factories. So the other one is processors. The processors don't produce anything. They just consume and, for example, build histograms, write to files, whatever. But by themselves, they don't drop any new objects in JANA framework. So this tutorial, we talked a lot about factories and processors, because we assume that for users, there's kind of the factories and processors what you write most of the time. But there are the 4th type of object called service. So you saw the services as the log service, and you saw services, for example, that loads the geometry from DD4HEP or loads ACTS or whatever stuff. So those are kind of global objects which probably we don't anticipate that users will write, so we don't cover them in the tutorials. But whatever, what happens once again if we recap? So plugins are just libraries that can add functionality to JANA. This functionality comes in 4 types of objects. Factories, event sources, which is almost the factories, processors, and services. And that's it. That's all the basics.
Yep. Thanks, Dimitri. That was nice. And all right, so before we go on into the last session or part, maybe there was one other thing I wanted to point out, because it might have gone back to the original question a bit, which was just to make it clear, when we attach a plugin, it does, if you attach, say, the tracking plugin, it doesn't mean tracking is going to get run. It means it's available to be run. So just like Dimitri is saying, it's like a shared library. You can attach a shared library, but it doesn't necessarily mean any of those things are going to get called unless it's being asked for from something like an event processor. which is going to make a histogram. So if I want to make a histogram that requires tracking objects, by the fact that that processor asks for those tracking objects, that's what makes tracking happen, not adding the plugin itself. If you ask for it and the plugin wasn't there, then it would give you a seg fault, or it actually give you an error. It would catch the seg fault, but it'd print an error saying that factory is not even available in here. And so then you'd have to look at why you don't have all your plugins in. But all right, so maybe we've gone on enough detail on that. Is there any other quick questions on factories before we jump over to the last part? I realize this is a wall of information. Is somebody saying something, or is that just background?
That might be background with me, actually.
Oh, okay, okay. All right, yeah, we fully expect that, you may run into some issues, and I very much hope that you will not hesitate to reach out when something is at all confusing, and especially if something is not working the way you expect it to. Please let us know. So,
So
maybe-
may I ask something to you here about the digitization? I have one question. So we are just smearing the hits with the pixel resolutions. However, we should reconstruct the hit from the charge. Then we are exactly getting the picture resolutions effect. Is it missing right now?
But you're asking, so wait, when we're doing the digitization, you're asking, what is the question?
My question is that we are just smearing the hits with the pixel resolutions. In principle, we should take the energy loss and we should convert into the charge, and we should distribute over the pixels, and then we should reconstruct the positions. This part is, yes.
Yeah, right now there's some very primitive digitization going on for different detectors in there, and it will, as you say, convert into charge, and then change that charge back into some value. As I'm not aware that there's as sophisticated algorithm as looking at individual pixels, applying saturation type effects in there. That's something that would need to be added by the detector expert. Right now, it's just simply sampling a Gaussian, I think. And
Yes, it's simple smearing.
yes.
So in the Athena also we have the similar thing, or we implemented the full digitization there.
Okay, so
The algorithms that you are using completely copied from Athena. So that's exactly what's in Athena.
Okay, okay. So in the Athena also we have this simple smearing. Okay.
yeah, we've been trying to copy over the algorithms from Athena as much as we can. I don't think anything new algorithmically has been written for EIC Recon yet. It's been more of trying to duplicate what was there, but set it up in this other framework.
Okay,
Right.
okay. Thank you very much. Yes.
Mhm. Okay, any other questions before we move on to the last section? Impressed with everybody who stuck around this far. All right, great. So Dimitri, you want to take it away?
Well, yes. So it's gonna be, I hope, a relaxing part, because there's no more code, JANA, and whatever, just clicking on the browser. And we'll talk about, can you see my screen?
Yep.
Yeah.
Yep.
Yes, and we talk a little bit, sorry, wrong browser. So we talk a little bit how you contribute to EIC Recon and where things at. So here is the, sorry, just a second. Yes, here is this last part of this tutorial. And first, you can find here that there are two repositories. So one basically that you used in this tutorial, which is EIC Recon, and the other one is that Jefferson Lab JANA2. So the JANA2 contains only the core framework with the kind of routines and scheduler and those prototypes of factories, whatever, and everything related to EIC goes to the EIC record. And that's important because where you file a bug or issue or question or whatever, so most of the time you would like to file them in EIC record. While maybe you'll find something in the framework that you would go to JANA. So I'm telling this because it's a little bit maybe confusing because everybody says that JANA2, but in reality JANA2 is a framework and EIC Recon is actually meet with algorithms. So if you're missing something with algorithms or whatever, you should go to this EIC Recon, and most of the time not to JANA, which is just a bare framework. All right, so how you contribute? There was a great tutorial by Walter, and I don't want to go over again about the workflow. I would just say that the workflow is standard with the whole of EIC, that whatever you do, whatever change in the code you do, you create an issue. So even if you discuss, and that's important, that for others to see what's going on and what is happening, it's really important that even if you, for example, discussed on some meeting that you do that, whatever, it's important that you start development with creating an issue describing what is happening. So let's just create some issue. And when you're creating issue, there's a template, is it a bug or a feature request? And actually feature request means that whatever improvement or you do, which is not a bug, actually goes to this category. So there's a kind of template for you. You probably know it, and probably wouldn't want to feel it right now, but please read it and feel if you feel it. So we now call it like test issue for the tutorial. And probably here you would like some description of what you do here. Now, what's important besides this EIC reckon issue item in the repository, we have EIC reckon project, so-called project and project board, where you can actually see the issues. So now we are sitting in the GitHub/EIC kind of parent directory. By the way, can you see the text on my screen without problems?
Yeah, it's a little small, but I can read it.
Yeah, okay, so it's basically just Electron Ion Collider namespace on GitHub. And if you click on the project, you will see just one project for now called Epic Reconstruction. When you click on it, once again, and you can find this link on the tutorial page also, you can see issues that are in the process, and some issues which is done for this project. You can switch to another view, which actually allows you to see which issues and what state and process. And that is actually a great tool if you think you would like to pick up something, whatever, to see it, because you know, in the issues, in the list of issues, it's sometimes less obvious who is doing what. And here is actually a great place for it. So, okay, let's go back to the issue. So we created an issue, and now we need to create our branch where we'll have our development. So there is a link called create branch over here. It's a small, and but when you click on it, it just creates you, ask you what should be the name of the branch, and you see that the name is actually copies the title of the issues and the number of the issue. So after you create a branch, you can see it in the JIT. I will use this software which actually show you nice tree, and you see that this issue appeared in the branch. So now we can actually start working and change the code. So I just check out this, and we need to change something. For this tutorial, I will just add one space in the end of the README. So here is our change, and we just commit the change. I probably will not accept it until the end and discard all the changes, but for now, we just commit and put the issue. So as soon as we put the issue, you can create a pull request. You probably, I would assume that you know what it is, but I just know that there's a tab called pull requests. And here's actually one or another button which you can click and create a pull request. So pull request kind of requests to merge your changes to the main branch. And please, please, please don't do what I will just do, is just write carefully and read carefully what is happening here. Actually, no, I will not delete it. It's just change and readme. And this is a huge feature which closes 155. And probably we don't need everything else. That there is no need on tests. I press it. There's this issue documentation itself, and we certainly communicated with you about this. It doesn't introduce any changes. It doesn't introduce any behavior. Now, what's important stuff? So there's a create pull request, and if you're still working on the code and you would like to continue, if you are not finished, there's a create a draft pull request, which will kind of say that this is still a draft. So what is the reason for creating draft pull request? That's actually on the next step. So as soon as you will create a pull request, you see that this continuous integration or automatic build and whatever will picks up. And it will try to compile. It will actually update the documentation and will try to compile and run some simple test. In future, the same as for Athena, we will have a lot of stuff triggered, like physics simulation, tracking, benchmarks, and other stuff. For now, EIC Recon just runs pretty simple build testing, and we'll be actually very soon working on adding all the benchmarks and stuff in this. But the idea is having pull request is that every time now when I commit any changes to this branch, this continuous integration will try to range, will make sure that it builds, everything works, all tests are passed, and in future kind of physics benchmark, another thing will be tested too. So as soon as it will be green and whatever, there's one more step from one of the core developers is code review. So here on the top, you can actually request somebody to review code if you mean somebody kind of special or somebody maybe with whom you discussed the issues. Otherwise, you can just leave it to us and one of the core developers will review the changes and actually commit the issue. So for now, I will actually close this pull request without resolution and probably delete this branch for this tutorial, but that's basically the workflow. So you first create the issue, what you're doing, you create a branch, you do your work and create a pull request. Then pull request checks all the tests, and with code review, we accept this contribution to the code. What about forks? So as I understand, unfortunately, Walter left already, but there's right now an issue if you create a pull request from your especially private forks, there will be a problem with running continuous integration with secrets. So it will be probably fixed in future, but for now, we recommend to create the branches in this repository. So
and I think as a convention, we probably just do want to push people to creating the branches right in the repository and making pull requests off of that. This is my personal opinion, but I think having the forks come from other private repositories somehow is going to make things even more complex. But others may disagree with me later.
Yeah, so just in case, and that's probably the last of the things, there is there is a discussions, and in discussions we discuss stuff about this thing. One of the thing in policy on JIT overflow. So that's if you have a strong opinion on this, you can go there and actually participate in the discussion of this thing, as well as maybe some other policies that might be done for this project. It's not many things are not set up as standards and not written as standards yet. So if you have your opinion, please comment, let's discuss it. So finally, about the contribution and code, the only thing that I can say that there's a file called contributing, where for now, very concise mode, we say that what kind of name, how we should make names, and some code samples and whatever. That certainly will be updated in the future, but you can look, I can say that, see all other code and try to write the same. So I don't know if anybody would like to do anything practical on this part, but I hope that this little part will actually help you to how to get started and how to create the issue and stuff like this. Any questions?
Yes, I have. So how to create this directory in our in that branch? Can you explain?
What do you mean by directory?
So it's my own, instead of fork, I want to create my directory inside that in the branch basically.
You mean like directory with files?
Yes. So instead of fork, I have to choose the another option. So how to create my own branch so that I can.
Okay, that was when you create an issue. And let's do this again. When you create an issue, let's call it test issue 2, right? So when and you put here what you're gonna do, so the others actually know what is happening, so no duplication of work happens. There's a button called create a branch. So you push on this button and it just automatically creates you a name of branch. But you can create it by means of there's no problem if you create it by means of just JIT, just create branch and put it, and that's it. It's just a convenient way to have the branch automatically created for you with the name corresponding to your issue.
Okay, thank you. Okay, thank you.
And you can see now this branch called 157 test issue 2, and 157 that correspond to this issue number. And here we already see it in the JIT branch. So in the JIT, so we can check it out and work on it.
Okay.
Any more questions?
Yeah. The participants are dropping off now as it's getting later in the day. And I want to make one other thing, because I don't think I answered it very well earlier. I'll answer it better tomorrow in the tutorial. But let me see. Oh, I'm not sharing the screen. Let me share the screen just a second. The question about, we don't have the matching of the truth particles in there, but one of the things I forgot to mention, you can put in things like MC particles, other things that have truth information that will go into your output file alongside of these things. So even if it's not matched up directly, you do have all the information in one file. That's the pod.io output file. You could do some primitive matching there yourself if you really want to do that, or get it truth information there. So that may have been part of the question before that I think I didn't answer very well. But anyway, that was it. Maybe before we close, does anybody have any other final questions or comments, or even advice for us before we do the tutorial tomorrow that might help your fellow collaborators who are going to go through a similar thing?
So I'll just say, first of all, this has been super useful. So thank you. The second thing I did have two additional questions though. So the first one is that I just wanted to get an idea for, so some of these reconstruction algorithms that are in here now, you said that they are very much in flux, and that part of the reason for this tutorial was to equip people to go in and start fixing that. I guess what I'm asking, what I'm curious to know though, is like the algorithms that are in there now, like, is there basically nothing there? Or like, if can I get calorimeter clusters out of this? Or is pretty much everything a blank slate and needs to be filled in?
It's not all a blank slate. So there are, actually, maybe what I should do is pull up here on the, just to go back to GitHub. The GitHub repository is a great kind of starting point for a lot of things. And as Dimitri was just talking about the issues, one of the early issues we had was a thing that he put in that made a few plots. Now, some of these have maybe gone a little out of date, but they have things like this in here. And, you know, it's mistyped, it's Roman pots. And this is from Athena. And so there is an algorithm called Sim Tracker Hits Collector, which we don't really need, but there's also an algorithm Tracker Digi. That's been put in there to make digitization of the Roman pots hits. Tracker Hit Reconstruction, that's been put in there. Far Forward Particles, that's been put in there. It's in a branch, I should warn you, this is in a branch that's not yet been merged into main, but the work has been done on this. Also, all of these algorithms have been done, but right now there's an issue where they're not linked up together quite right, that we have to fix, and we'll do that over the next couple of days. But then you'll be able to access any of these objects in here coming from this. So there is some work in there, but it's mostly on the digitization side of things. There's some clustering in there that hasn't been, I'd say there's a couple of minor things that need to be fixed in it to get it working right. And the tracking is in there, but that doesn't necessarily mean that even the stuff that we are putting in is, you know, fully developed. This is what was in the Athena software stack, and there was a lot of work done there, but it's not necessarily even the end result for that, because it was done, you know, in a short time scale. So we
Exactly. Okay. I guess so for some of this stuff, it's like you could expect to get the same performance that you got last year, and that might not be final. Like, there still could be improvements, but okay. And then the other question I had was that I just want to confirm that basically starting with this simulation campaign that's upcoming just in a couple weeks, this is going to be the simulation output going forward, right? So we are now kind of converging on this as the official, you know, Epic simulation.
Right. You're saying as opposed to the Fun for All output versus the pod.io output.
Yeah, because I guess one of the things I'm kind of trying to figure out is that, you know, I have people are asking about getting, you know, kind of physics results from the simulations, and I'm trying to balance, you know, how much should I be investing in trying to make stuff work in the old Fun for All framework versus just going all in and you know, doing the work to start getting results out of JANA2. And it sounds like it sounds like the latter is kind of the wisest path.
It's a very valid question though, because you know, it's not like people have had a lot of time to get used to this format, and especially with JANA2. JANA2 is behind schedule on where we expect it to be by now. And you know, we could take two tacks. One is, oh, let's make a processor that tries to write out trees that look a lot like the Fun for All, and that'll make it very easy for people who have macros and programs that already work off of that. But on the other hand, we know that that's not something we want to sustain forever. We want to try to converge on a single output format. And the format that we have converged on is this pod.io root file format. So
okay.
I think it's probably better for us to pull off the Band-Aid with this simulation campaign. And then that's just, I think, the way that we're going to do it.
And so sorry, did someone else have a question? I'll let someone else, because
No, I just wanted to make a little comment that what is happening right now, that we have pretty identical output to what was in Athena, because Athena used the same pod.io, and because of this, we kind of created the same name, so at least Athena files, I mean, analysis files can work on the output. And one of the things we're working now is to make sure that those benchmarks are working with JANA output. At the same time, there are several names in the data, which, for example, irritates me because they are pretty ambiguous or not correct or out of something. So there may be a little changes, but anyway, the output is going to be pretty close to what was in Athena, but this is basically just because we're using pod.io.
Oh, okay, thanks for clarifying that. Then one last question, let's say someone like me says, okay, I have these, calorimeter clusterization algorithms and I want to put them in here. Who's kind of responsible? Who should I be communicating with that?
Oh yeah, that's another great question.
Like, should I be talking to the calorimetry working group and saying like, oh, I would like to try to put this in to EIC Recon, or is everything being kind of managed by the software group?
Yeah, it's an excellent question. So what the way it should work is this should be going through the calorimetry group, who should have ownership of this stuff. And if they have specific things they need to work with the software group on, then we would get pulled in for that. But in practice, I don't know that the calorimetry group has really come in and done anything in EIC Recon. I say it's behind schedule, and so I don't blame people necessarily for this now. So if you went to them and said, oh, I want to do this, you may just get kind of blank stares a little bit. But I think that is the way that it should work.
Okay,
It should be
like
coordinated through them.
Okay, so like kind of the way that the operating principle is that the detector working group should be kind of have ownership over the reconstruction of their detectors.
Yes.
Okay, well, so I've been trying to attend the calorimetry group working group meetings anyway, so I'll bring this up and see if this is something I can start contributing to. So okay,
Yeah,
thank you.
Well, I can say that since it's now a little bit kind of flipped from the upside down, so if you have something, you can start with software, because we at least can point you where to start, what is happening, and meanwhile contribute to calorimetry group. I think the same happens with the tracking actually group.
Okay.
Yeah, I think the message is don't feel like you can't start putting things into the repository until you've gotten an okay from them. You can always put stuff into a branch, and you can even always make a pull request, with a draft pull request on there. But yeah, I think it would be good to at least let them know, give them a heads up that you're working on this. I can't for the life of me imagine them saying, wait, we don't want you putting anything in there when they're not actually doing it themselves at this point. So
yeah, we definitely won't do this. We'll do whatever we can to have you adopt as fast as possible and implement whatever you do. Maybe it's a good way to stick in something that otherwise cannot be sticking.
We are eager for anybody and everybody to put stuff into the repository. So we don't want you held up by something. But yeah, coordinating with the calorimetry group will eventually be necessary. So it might be a good way of getting them involved too.
Okay, thank you.
Right, sure.
Just a quick question. So is it the root file we recently written, or just it is always creating the root file for the reconstruction, like with the Monte Carlo particles and the Rico particles?
Yeah, so like here, this will create one root file that has both of these things in it. So in fact, I ran this. Whoops, where did my thing go? I ran this, and so you can see that what gets put into the file are both, it's maybe a little bit tiny to see, but this MC particles is in there, as well as reconstructed particles.
Okay.
So they all go into the same root file.
Okay, but this was developed recently. Some days before it was not there. Yes,
Well, it depends if, I mean, you could see where when I ran this, I had to tell it I wanted both of these in there. So if you didn't put both of those on, it might not have worked.
So there's a little context. So that is something that Shab was waiting, and this change that actually saves this file like this was made, I think, before this weekend, so on this weekend. So I wanted to send you email with all the updates, but this after the tutorial. So we're asking about this on tutorials. What's important, those names that you put in this collection, David, if you could scroll up and show there is a table with those names. So you can look at the data produced by JANA and save any of this data.
So yeah, and you, so this one has the reconstructed particles in it. One of the things I was noticing though is it does not list here the names of the things from the pod.io file, which is confusing. So the MC particles doesn't show up in that list. Those are, because there's no factory producing it, it's just something read from the input file. So if you really want to know what's in the input file, you have to do something like this, where you set this parameter, print the type table to 1, and then you give it the name of some pod.io file. And when I run this, it'll print my factories, but it'll also open that file up, and it'll give this list, which unfortunately, I think we need to flip this around. This now has the collection name on the left and the data type on the right. This is where you get the list of exactly what's in that root file. You can also just open the root file and figure it out, but this is where you would see MC particles at, something that you want to copy over from the input file to the output file.
Yes, one more thing I want to ask. So in the reconstruction, do we also store the track parameters? Because I need track parameters there also in the reconstruction.
Yeah, it's in the trajectories. So David, if you scroll up, there will be EDM for EIC trajectories, and they're going to be track parameters. So it's closer to the bottom. So it's something
not
like
this one.
no, it's on the closer to the bottom. So there's a track parameters and reconstructed particles. Yeah. This is one, and the other one, if you would like to raw results from the ACTS, it's on the top. It's drag trajectories over here.
Okay.
Yes. So this central trajectories is something that comes directly from ACTS.
Okay. So if I want to write in the root file, let's say, for example, this track parameters, what should I pass? Some flag I should pass, yes?
Yeah, you would just pass this in your comma separated list. So,
Okay.
right? So I would have the this thing wherever it went. I should just be able to add this. And now hopefully this is not going to crash on me right in the middle of the thing.
Hopefully.
I had some issue earlier. Now there it's working. So it's writing it out. And then we can look in the root file and we will see the track parameters tree will have been added to it. Branch right down here. You have all this, yeah. Type, I guess the type is always 0. Look, yeah, location error, Q over P. These are the things I guess you're looking for.
Yes, actually, I'm looking for it. This is local parameter L0 is there, yes? No?
I'm not sure which one you're talking about. The local parameter what?
L0 parameter, it's the first parameters of the track, like 1 over this local parameter on the surface.
You mean this DCA? I think it's in the drag trajectories. I think it's in the trajectory.
May have to, yeah.
So
you may have to
I'm not sure, but I'm pretty sure that we can put it offline or at least have a separate meeting with all those exact things.
Yes, because I write separately root file and then I extracted the DCA resolution. It's blank histogram, so I want to use facilities actually. Momentum resolution, everything is coming blank. I don't know why. What is the problem there? So I want to use this facility which creates the root file, and then I will use that so that it's a standard.
Yeah, that was fixed or added. I don't know what's the correct verb here is during this weekend. So if you try it right now, they will be filled.
Thank you. Thank you.
All right, great. Any other questions? All right, if not, I appreciate all of you that have stuck around this long, and certainly don't hesitate to contact us with anything else. And enjoy the rest of your Monday.
Thank you.
Thank you all. Bye-bye.
Bye.
Right. David,
Yeah.
I have one thing to ask. So for the scaling of the magnetic field, I am using this scale factor. Is it fine? I send on the chat. It takes that factor automatically when I take the 1.7 Tesla, or is it? I don't know, but
Yeah, that should work. Yeah, I saw it in your email. Have you seen it working actually?
yes. Now the plots is really very different. It's with comparison to we lose so much efficiency now. It's I don't know how it's very different plot.
Okay, so Shyam, I'm have to apologize. So I didn't send you all updates. That's because for the weekend we were pretty busy with preparing for these tutorials. Now these tutorials are done, and I will first of all first let's add material map, send you how to use material map, and actually we have to check if material map from the default app is used by default. That's first. So second, I want to ask actually you if you can check on the magnetic field, but for me your parameter is correct, so this magnetic field should be scaled all right. So, but at the same time, have you tried not to change this factor and try with 1 and 5 Tesla magnetic field? And see that it's because 1 and 5 and it's pretty, yeah. So then the second one is third one or whatever, fourth one, is that as I saw in the meeting, so I'm working on this measure. By the way, this measure will be working both on the calorimetry and with something. So it will say that it kind of matches 99% of cases. At least Sylvester actually told me. So as soon as I will finish, I will let you know. So kind of, I'm sorry I didn't update you during the weekends, but I will update you as soon as I will finish those things.
Okay. Is it recording stop? Then I can.
I don't think I did stop the recording. I'm sorry, I forgot to. Thanks for reminding me. Stop
Okay.
recording.
So if you want, I can show you how it looks like efficiency. Maybe if somebody has comment, you can comment